Hello everyone. Today we are going to solve GFG problem of the day. Make matrix beautiful, and its expected time complexity is big of m square, and space complexity is big of one. That means constant space. So we'll be solving those boundaries only. So let's see what the problem statement says. I hope you have already gone through the problem statement, but if not, I will be explaining. So we have been given a square matrix. The square matrix I means is number of rows equals to number of columns. So if number of rows is n, number of columns will equal to n, that will be n square. N square, the size of the matrix. So we have been given a square matrix, and here what we have to do is we need to make the sum of each rows and each columns equal, and by doing so we can increase any element at once by one, but any number of times we can increase an element, but at once only by one. So by doing so we have to make the sum equal by increasing. We can only increase, and in the end we need to return the minimum number of steps needed to make the rows and columns equal. So let's see what the current sum, then we will try to make the sum of rows and columns equal. Currently, this row sum is 2 plus 1, 3. This is 7. This is 3 plus 1, 4. This is 4 plus 2, 6. Now, what we have to do is we can only increase at each step one by one, only once. Like only we can increase one, but any number of times. So currently it is 3. So 3, how much should we increase? We can increase it by 1, then it will become 4, increase it by, like any element if we increase, the sum of this row will become 4, 5, 6 and 7. So if we increase 1, it will become 4. If we again increase, it will become 5 and so on. So even we can increase it till 8. But since we have to increase it in such a way that all of the rows and all of the columns are equal. Okay. So these 3, how much till we increase? What if I increase it till 6? If I increase it till 6, this 7 will say your sum is 6, my sum is 7. We are not equal. Okay. So I say I am increasing this 3 to 7. And this 6 will say I am not equal. So I will say I will increase you as well to 7. And this 4 will say I am not equal. I will say I will increase you to 7. So why we need to make everyone till 7? Because this 7 can't be reduced to 6. So that's we have to increase whatever the smaller is till 7. And what is this 7? This 7 is nothing but the maximum sum among all the rows and columns. So what we will be doing is we will be making rows and columns sum equal to the maximum columns. Okay. So we got the idea that we will be taking 3 to 7. This 7 is already 7, no change. This 6 to 7 and this 4 to 7. So if we got this, let's move ahead and let's see how we can do it. This is 1, and for 3 to making 7, I need to do plus 4. So this is part, and for this 4 to make 7, I need to do plus 3. So this one, if I do plus 4, this is satisfied, but it will say I am 8. So because this row is coming here as well as here. So we can't increase it by 4 now. But if we increase it by 3, this will be satisfied, this will be not satisfied. But we will say we will increase you by 3 and we will see that one later. So this is increased by 3 and it is satisfied 4 plus 3. Why? If we are increasing this, see, this is a common point. This one was common for both this one and this one as well. So that was the problem. And so we increased it by 3 only. Now we came here. This is this is 2 plus 1, and here also we increase 3. 3 plus 3, 6. We say let's increase u by 1. Now this is satisfied 3 plus 4, all done. This is satisfied 3 plus 3, 6 plus 7, done. This is 3 plus 3, already 7. This is 4 plus 2, 6 plus 7 plus 1, that is already satisfied, that's done. So how many steps we took? Plus 3 here and plus 1 here. We took 4 steps, that is our answer. I hope you got what we have to do, but we have not reached the solution. Now here we will revise our solution and we will move ahead to code. So what we can do is we have to increase it. So first we will calculate the sum and we will see whatever our maximum sum is. We will try to increase everything till there. Okay. So its sum is 6. Let me write down the sum. This sum is 3 to 5 plus 4, 9. 3 to 5 plus 1, 6. This one 4, 3, 7, 1, 8. This one 6. This one 7. So I have written the sum. Now what I have to do is find the maximum sum among rows and columns. 9 is the maximum sum. So if 9 is maximum sum, I will be making everyone equal to 9. So this row sum is 6. I want to make it to 9. So I would say, hey, can I increase you by 3? If I increase it by 3, it will say no, you cannot increase it by 3 because I am 8. I can increase only by 1. So I say, okay, I will increase you by 1 only. That's done. But current increment is plus 1. We have to increase it by 3 to make it equal to 9. So I say, hey, can I increase you by 2? So this, I tried to increase. This 6 plus 2 I checked. This is still not 9. So I say, yes, I can increase you by 2. Now this we will not increase because we had 3 and we have already taken that. So that is done. This is equal to 9. That is done. This is already 9. No need to change. This 3 plus 2, it is currently 6. So can we increase this? No. If we increase this 3, it will change this row as well. So we will not increase. Now this 2, we can increase it by 1 because 6 plus 2 was there, plus 1 if we do, that is done. And now how much we can increase it here? We can increase it by 2. So let's say we increase this by 2. So this has contributed here as well here. So here it is also contributed to, that is done, that is done. And we have made all of our equal to 9. So the steps if we see 2 plus 1 here 3 and 2 plus 1 here 3. Total number of steps is 6. So that we will return. But let's me again go to the code and explain or see one observation. So the question has not asked us to tell us where you have increased. And what is happening is, if we are increasing anything here, this will contributing to this one as well. And the question is not asking me to return where I am increasing. So what if I just make this row only? I just consider this row only. And I will not even consider this column. So what I'm saying is if I try to make the sum of this row only equal, and I will not consider these columns, what will happen? So if I see I need to increase 3 in here, I see I don't need to increase anything here. If I see this is 6, I need to increase 3 here. So if I see, if I can increase three in this column, in in this row, that will eventually contribute to this, but not optimally, definitely. But do we need to consider that thing? Do we need to consider adding here? No. I know, because if we add 3 in this row and make it equal to 6, that will be contributing to this as well. And we don't have to take care about this. Why we don't have to take care? Because if we see here, that was already contributing. And since that is already contributing, those will eventually come here. Now, let's say I'm increasing by 3 anywhere, plus 3 I did here. And you will say, hey, this is unbalanced. 8 plus 3 is higher than 9. So, it will be unbalanced. But there is a catch here that we don't have to tell, like where we have to change it. Where we are changing, we don't need to worry. That will definitely contribute to this one, but it's optimal. If we increase this row by 3 and nothing increase, nothing this, it will automatically make it equal, and we don't have to care about that. So I'm saying, if we consider only rows and not consider columns, it can give us our solution. So what we have to do is, we just have to find the maximum among rows and columns, and we can run a loop either in rows and either in columns, and see how much we need to increase. 6, we need to increase it by 3. 9, no need. 6, we need to increase by 3. That is our answer. If we see here, 8, we need to increase by 1. 6, we need to increase by 3. 7, we need to increase by 2. 3 plus 1, 4. 4 plus 2, 6. So we can either consider rows and columns, and that will give us our answer. So I hope you got the point, that if we consider only rows, that will take care of the columns, and we don't have to consider that separately. So what we are going to do in the code, we will run a loop, we will find the sum of rows, and we will find the maximum sum of rows and columns. So maximum we find 7, 9, and now we will again run a loop, either in row or column. We will see how much we need to increase this 6 to make it 9. So we find that it is 3 we need to increase. So that we will take this as our steps. So this is 6 plus 3, and here also we will find that it is 6. It is 3 less than 9. So here also we will need 3 steps. So 3 plus 3 at the end, whatever we will get, we will keep summing that and we will write down that. So let's move ahead to code. But before moving, let me copy. I have already written the code. I will be explaining you the code. So let me copy it first. And let me paste it here. So what I have done is, I have taken row maximum, this, and column maximum, this, and maximum sum, like whatever will be the maximum sum among rows and columns, this will be stored. And row, this is nothing but row sum, like sum of the rows, and this is sum of the column till now. So if you see this code, what it does is, first let me go to the code, and let me go to the board and tell you what it is doing. So what that code is doing is, first it is starting from here, and it is first going through all the rows and then it is going through the columns and getting the sum. So going through row, it is getting the sum 6. Going through the column, it is getting the sum 8. And now, after it has row sum, it has column sum, it will find among 6 and 8, maximum is 8. So it will be stored 8 till now here. Again, it will go, it has gone till here. So it will go from this to this. So it has found this sum is 9. Again, it will go from this to this. It has found 6. And among them, maximum is 9. So it will store 9. So this is what that code is doing. And it is calculating the maximum. So first, I'm initializing rows and columns like 0. Then first I'm running in row. Then calculating whatever the rows maximum. Then I'm running in column and calculating whatever we have got is if that is greater than my answer, store it. So in that way, that sum will have maximum among rows and columns, whatever we have got till. So once we have got the maximum, we will run a loop in either row or column and see if whatever we need to whatever we need to decrease. So what this loop is doing, let me tell you, let me explain that once. So that code, what it is doing is, I'm running from this till here and see this sum is 6, okay, and I got the sum 6, and what I have to make 9. So if I increase from this 9 6, I will get 3. So that is that code is doing. So if we see, I'm required to, I'm initializing to maximum sum. That maximum sum is nothing but 9 in that case, and we are running a loop and we are doing the sum of that row, and after summing that row, sorry, and we are running a loop and we are decreasing every element from our maximum sum. So like this, from here, from 9 we decreased 1, and then from 9 we decreased 2, and from 9 we decreased 3. That is nothing but our sum. From 9 we decreased 6, and finally whatever is remained, that need to be considered for our answer. So whatever is remaining, I have plus summed it to my answer, and finally I'm returning the answer. So let me submit the code. It should run. It is already 18 minutes long. So this is okay. So let me rerun. So let me submit it once again. There was some issue. So it got submitted. Now you may ask, this we are running a row. Now what will happen if we run it in a column? So the same way, if I uncomment this part and run in a column, that will also work. So here if you see, I'm doing matrix J of I. So J of I means we are keeping the column constant. Like J of I means, earlier what we were doing is we were going like this. Now J is moving in the place of this. So J will be keep moving and I will be fixed because I is outer loop. So we are running like this. And if we run a loop like this, we will consider all the elements in that column. So if we see, that is already also submitted. So I hope you got the idea. If not, comment. I will be happy to solve those problems. And till then, keep learning. Bye.